Hey guys, this is Ronald from MathBase. Today we'll learn about the special triangles. Let's say you're asked to evaluate one of these expressions, the sine of 60 degrees, cos of 45 degrees, and tangent 30 degrees. Usually we could just use a calculator to work these out, but there will be times when you are expected to do this by hand. That's when the special triangles become useful. This is an equilateral triangle. Each side is 2 units long, and each corner is 60 degrees. If you cut it in half, you will get a right-angled triangle. Its longest side is known as the hypotenuse. From the equilateral triangle, we know this is still 2 units long. This new triangle has a base of 1 unit, and using Pythagoras' theorem, we can calculate the height to be √3. These two sides are known as the legs of the right-angled triangle. The bottom corner is still 60 degrees, but the top corner is now 30 degrees since we cut it in half. This is one of the special triangles, and this is one way to build it. This is a unit square. Each side is 1 unit long. If we cut it in half diagonally, we get a right-angled triangle again. But this time, the legs are each 1 unit long, but the hypotenuse needs to be calculated. Using Pythagoras' theorem, we can work this out to be √2, and this is how you can build the second special triangle. With these two triangles, we can begin to work out our questions from before, but we need one more thing, Sohcahtoa. They're an acronym for 3 separate equations. Sine of an angle equals to its opposite side dividing the hypotenuse. Cosine of an angle equals to its adjacent side dividing the hypotenuse. And tangent, which is the opposite over adjacent side. Keep in mind that for whichever angle you're looking at, the opposite side is always away from it. It doesn't touch the angle. The adjacent side would naturally be beside it. Only the legs can be called opposite or adjacent. Now we can draw out our special triangles and use Sohcahtoa to find the answers. For the sine of 60 degrees, we need to use the 60-30 triangle. To draw this correctly, make sure the right-angled triangle is stretched to one side. This avoids mistaking it for the other triangle. Next, label the smallest corner as 30 degrees, with its adjacent side as √3. This way, you won't mix up the side lengths. Now label the rest in. When you first practice this, it may take some referencing, but if you practice for a week straight, you'll find yourself remembering it quite well. It doesn't take long at all. It would be amazing if some of you can go further and visualize it mentally. Now that we have our 60-30 triangle, let's use our acronym to tell us the next step. The sine of 60 uses SOH. So sine of 60 equals opposite over hypotenuse. Right, so all we need to do now is shade in 60 degrees as our corner and circle its corresponding opposite side and hypotenuse lengths. Now that we've identified the sides we need, we can write the next step as sine of 60 degrees is equal to √3 over 2, which is an exact value. Your exams usually prefer this, so we'll leave it here and move on to the next problem. To find cos 45, we need the other special triangle, which I like to call the 45 triangle. As we know, its legs are equal in length, so draw it accordingly, like this. The 60-30 triangle should always look very different from this. From here on out, it's the same drill. We want to find cos 45, so we need to use the acronym CAH, which in this case means cos 45 equals adjacent over hypotenuse. You can choose either corner since they're the same, so I'll pick this one. There's always a lot happening in the maths problem, so the point of shading in our corner is to help us focus on what we're doing. Next, circle the correct adjacent and the hypotenuse. From here, we just update our equation to be cos 45 equals 1 over √2. This is an exact value, but if you rationalize the denominator like this, you will get √2 on 2, which is usually preferred and more useful in maths. Okay, moving on to our last problem. Since we're finding the tangent of 30 degrees, we'll need to draw the 60-30 special triangle again. And this is super important. If you want to memorize it quickly, Draw the triangle every single time you need it. Don't recycle what you drew before. So it's the same deal with this problem at this point. Just pick out your 30-degree corner, mark out its opposite and adjacent to match TOA, and write in the numbers. So tangent 30 will equal 1 on root 3, or root 3 on 3, if we're rationalizing the denominator. And there you have it. If you've always wanted to be good at something in maths, well, this is your chance. Do these questions, making sure to get each one right before moving on to the next. And when you're done, do it again. I do have a way of implementing this for my students to help them master it quickly, but I'll cover it in another video. So be sure to check that out. So I hope this video has helped. If it has, please leave a like, comment down below, and subscribe. Thanks guys. See you in the next one.